Hi guys, welcome to the Chapter 5/Chapter 6 review video. And just so that the video isn't 3 hours long, I'm going to be as concise as possible, and I'll kind of assume that you sort of know the formula that I'm going to use, or you know the formula that we're using, so I'm not going to maybe write out the formulas as much as I normally would, like the base formulas. I'll just reference them, and then put in the numbers then that I would be using with the formulas, as opposed to writing out the formula, then writing out the formula with the numbers in and all that kind of stuff. So without any further ado, let's get started. Let's get through this thing. All right. Number 8. Assume that the waiting time x for an elevator is uniformly distributed between 0 and 6 minutes. For the probability of x. F of x is equal to 1/6 0 to the x, or x is between 0 and 6, 0 otherwise. Okay, B. The reason that the formula that we use there is f of x is equal to 1 over d minus c, d being the upper part of the range, c being the lower part of the range. And so it would be 6 minus 0, which is 6. That's that. And that's over the interval from 0 to 6. 0 otherwise means that the function is not defined anywhere other than between 0 and 6. Graph the probability of the curve x. So we said that it's defined between 0 and 6. So here's 0, here's 6. And we know, because the function value is constant, that the height of the curve is 1/6. So this is the graph. C. What is the probability of x between 2 and 4? And we just go back to the formula that's given to us for this distribution, and that's that the probability of x between a and b, so a is less than x is less than b, is equal to b minus a over d minus c. So b minus a is going to be 4 minus 2 over d minus c, which d is 6, c is 0. We get 2 over 6, or 1/3, or 0.33333333, repeating. Next is the probability that x is between 3 and 6. Same formula, 6 minus 3 over 6 minus 0, which we get 3 over 6, which is 1/2, which is 0.5. Next thing is E. So this is a bit tricky. So probability that x is, I guess this is a bracket, probability that x is between, that's a less than or equal to, x is between 0 and 2, or between 5 and 6. So this is just all one probability. So essentially we're just going to do this formula twice. So we're going to say 2 minus 0 over 6 minus 0 plus 6 minus 5 over 6 minus 0. And then we're going to get 2 over 6 plus 1 over 6 which is equal to 3 over 6, or 0.5. And then on to F. F says calculate the mean, the variance, and the standard deviation. So we have formulas for that. So the mean is mu of x is equal to c plus d over 2, which is just going to be 0 plus 6 over 2. My computer is doing that again. I am really annoyed with it, but you know, that's a 3. And then our sigma x formula is d minus c over square root of 12. And so that's just going to be 6 minus 0 over the square root of 12, which is 6 over the square root of 12, which is equal to 1.732. And then the variance is going to be that squared. And we just know that that's going to be 6 over 12, 6 over the square root of 12 squared, which is going to be 36 over 12, which is 3. And then lastly, G, find the probability that the waiting time of a randomly selected patron will be within 1 standard deviation of the mean. Okay, so this is asking us to come up with a range first that 1 standard deviation away from the mean is. So we first find a range, which is going to be mu of x minus 1 standard deviation. So we would say 3 minus 1.732 from 3 plus 1.732. Okay, so our range right here that we're going to be finding the probability from is going to be 1.268 to 4.732. And so then we want to find the probability that x is between that. So 1.268 is less than x is less than 4.732. And that's just going to be that same b minus a over d minus c function, or identity formula, whatever you want to call it. So we would just say 4 minus 732 minus 1.268 all over 6, 6 minus 0. And that's going to give us, at the end of the day, 0.577. Okay, so that's that. So that's number, I believe it was number 8. Yes, number 8. All right. As always, guys, let me know if you have any questions in the discussion boards. I know that I'm going to be running through these very quickly. So if I didn't explain something well, or if you're a little bit confused on something, please don't hesitate to ask me questions in the discussion forum. And yeah, that'd be great. All right, number 9. The customer service department for a wholesale electronics outlet claims that 90% of all customer complaints are resolved to satisfaction of the customer. In order to test this claim, a random sample of 15 customers who have filed complaints is selected. This is problem 523 on page 204. A. Let X equal the number of sampled customers whose complaints were resolved to the customer's satisfaction. Assuming the claim is true, write the binomial formula for this situation. Okay, so we say A, and then we'll say X is binomial with N equal 15 and P equal 0.9. Okay, and then furthermore we would just write out that function, so the P of X function, which is just going to be 15 choose X times 0.9 to the X times 0.1 to the 15 minus x. So that's A. Use the binomial tables. See table A.1, page 599, to find each of the following if we assume that the claim is true. Okay, so I put this table for you guys on Springboard. I do believe that it is actually on page 599. I think in an earlier worksheet it maybe said a different page number, but yeah, I think page 599, yes, yep, is where the tables start. So going forward, I would always use these tables. We're not going to give you a problem that you can't use these tables for. And if we do, then it'll be specifically known that we want you to use the formula, and we're not going to have you calculate like a million values. You'll just have to calculate one, showing that you know how to use the formula. But other than that, use the table as needed, and use it, I guess, to your advantage as easy as possible. So B1. So B1, probability that x is less than 13. Okay, and I think that the easiest way to go about this is to say 1 minus the probability that x is equal to 15 minus the probability that x is equal to 14. Okay, and let's go over to the table. So we want to find what our n value is, so the number of trials that we're doing. We see we have 2, 3, 4, 5. We want to find 15. There's 15 right here. Then we want to find the p-value that we're using. So these tables are set up pretty interestingly. So the p-values on the top go in ascending order, and then you'll notice the p-values on the bottom go in descending order. Okay, so the way that you'd read this table is if you're reading it from the top, so 0.05 all the way to 0.5, then you would use the x values going in descending order here. Right, so x equals 0 for 0.05 is right here. X equal 8 for 0.05 is right here, so on and so forth. But if you have a p-value that is 0.5 or greater, like say 0.7, if you want to define like the x value for 0, you're going up, right? So the x value, if x equals 0, is right here. So you're referencing the right-hand side, not the left-hand side. So 0.7 p-value, we assume that we have 8 successes, say, so x equal 8. So we go over here, we find where 8 is, and run it on over here. So we get 0.0811. Okay, so anyways, let's look into how we're going to go about solving our problem. So we need to know the probability that x is less than or equal to 13, and rather than count up and add a bunch of values up, let's just add a few up. So we said let's call that probability 1 minus the probability of x being greater than 13. So that's going to be 1 minus the probability of x equaling 15 and 1 minus the probability of x equaling 14. So what we do, we go find our p. So p is 0.9, okay? And so now we need to know what our values are for x equal 15 and x equal 14. So we just go all the way up to 15 here. We get 0.2059. Uh-oh. So 1 minus 0.2059. Don't know why my pen has decided to go a different color. And next value is 0.3432. So 1 minus those values is 0.4509. B2. B2 is the probability that x is greater than 10. And let's look at the table. So we're at our 0.9, we go up greater than 10. Well, we have a lot of very small values for less than 10, right? So if we're referencing from 10 over here all the way on over, 10 is 0.0105 all the way on down here. So I think it would make sense to just say 1 minus less than 10, or less than or equal to 10, right? So we'd say that this is 1 minus the probability of x is less than or equal to 10. And so then all we do is we just say 1 minus, and then we just add up all those values that are probabilities of less than or equal to 10. So we go over here, 10, we have 0.0105, 0.0019, and then 0.003, and then the rest are zeros. And that is 0.9873. B3, probability that x is greater than or equal to 14. So that would just be greater than or equal to 14. We actually have already calculated the complement of that, right? So in B1 we calculated the probability that x is less than or equal to 13. Well, greater than or equal to 14 would just encompass the values of x equal 14 and x equal 15. So we could actually just say, well, this is just 1 minus probability that x is less than or equal to 13, which is just 1 minus 0.4509, which is just equal to 0.5491. B4, probability that x is between 9 and 12, including those values. So we would just add up x equal 9, x equal 10, x equal 11, x equal 12. So 9, 10, 11. So 9 is going to be 0.0019. 10 is 0.0105. 11 is 0.0428. And then 12 is 0.1285. And that's all going to equal 0.1837. And then B5 is oh, my computer's doing something funny. Okay. Is the probability that x is less than or equal to 9. And we can use we can actually use no, I think we'll just add them up because those are all very small values. Yeah. So less than or equal to 9, 0.0019 plus 0.003. Okay, C. Suppose that of the 15 customers selected, 9 had their complaints resolved satisfactorily. Using part B, do you believe the claim of 90% satisfaction? Explain. Okay, well, I'm not going to write it out. I'll just explain it to you. I would say no, because if this were the case, then there would have only been a 0.0019 probability that this would have occurred. That's roughly a 1 in 526th chance. The way that you'd come up with that number, that 1 in 526, is you just take 0.0019 and you just take the reciprocal of that. So you just take 1 divided by 0.0019 and it'll give you a number like 526. So the idea is like that if we assume that everything is true, we assume that 90% of all customers are resolved satisfactorily, and we run the test and only 9 of them are resolved satisfactorily, we can see using this binomial probability that the probability of that actually happening is 0.0019 is very, very, very slim, 1 in 500 chance. So we're kind of saying, well, you know what, we believe that it wasn't a 90% chance of satisfaction because it's so unlikely that we would have exactly 9 in this scenario. So that's the way to look at that. Number 10, an industry representative claims that 50% of all satellite dish owners subscribe to at least one premium movie channel. Okay, in an attempt to justify this claim, the representative will pull a randomly selected sample of dish owners. Okay, and that's on page 204. It's 525. Okay, so the first thing I like to do with these is I like to read through the problem and try to figure out what's going on and try to figure out what they mean. But here, let's read A first, and then we'll get back to reading 10. Suppose that the representative's claim is true, and suppose that a sample of 4 dish owners is randomly selected. Assuming independence, use an appropriate formula to compute. Okay, so let's read 10 again. An industry representative claims that 50% of all satellite dish owners subscribe to at least one premium movie channel. Okay, so at least one. So subscribing to this premium movie channel, to at least one, this is what they're defining as success. Okay, that's going to be deemed as success. Okay, and so because that's deemed as success, we're going to be like looking at this as if it's a binomial. Okay, you'll see why in the question here. The probability that none. Okay, so suppose that the representative's claim is true, and suppose that a sample of 4 dish owners is randomly selected. So 4 dish owners randomly selected, so that's going to be n equal 4. The probability that none of the dish owners in this sample subscribes to at least one premium channel. Okay, so let's do A1. So first thing, we know that x is going to be binomial with probability of 0.5 of success, right? And then n equal 4. So it's just saying the probability that none of the dish owners in the sample subscribes to at least one premium movie channel. So basically the probability that there are no successes. So the probability that x equals 0. So probability that x equals 0, let's just go do this at our table. So we look for a table of n equal 4 and where the p-value is 0.5. So we scroll up, n equal 4 table in the binomial, and 0.5 probability. So because it's 0.5, you can either go down or go up. Doesn't really matter. That's the only one that works that way. So 0.5, where x equals 0, 0.0625. Okay, easy enough. A2. Probability that more than 2 dish owners in the sample subscribe to at least one premium movie channel. So at least one. No, sorry. More than 2. Probability that more than 2. So probability that x is greater than 2, not greater than or equal to. It does say specifically more than. So that's going to be the probability of anything greater than 2 in this sample of 4, right? So that's going to be the probability of x equal 3 plus the probability of x equal 4. Okay, and we just go to our table, and x equal 3 is 0.02500, or sorry, 0.2500, and x equal 4 is 0.0625. 0.2500 plus 0.0625 is equal to 0.3125. Suppose that the representative's claim is true, and suppose that the sample of 20 dish owners is randomly selected. Assuming independence, what is the probability of that? Blah, blah, blah. Okay, so now we have a new binomial distribution, right? So x is binomial with still probability of 0.5 because that was the owner's claim, but now n is equal to 20, so we need a new table. So we go over to the table, we find n equal 20 table, there it is. Okay, so B1 is asking us, what is the probability that 9 or fewer dish owners in the sample subscribe to at least one premium movie channel? 9 or fewer. So that is the probability of x is less than or equal to 9. Okay. And this is just going to be, unfortunately, the probability that x equals 9 plus the probability that x equals 8 plus the probability that x equals 7, all the way on down to the probability that x equals 0. Okay? And I'm just going to give you the answer, and we'll talk about how we got it. It's 0.4119. And the way that we got that is we go to 0.5 p-value probability, and we would just add up x equal 9, which is here. So 0.1608, x equal 8, 0.201, 0.1201, x equals 7, 0.0739, 0.0370, 0.0148, all the way up. B2, more than 11 dish owners. So probability that x is greater than 11, not greater than or equal to, but greater than 11. Okay, and this is going to be I'm going to kind of do this one a fancy way. We're going to kind of use what we just solved, and in accordance with this, you don't have to do this. You can do it a couple different ways. So probability that x is greater than 11. What you could do is you could just add up all the probabilities of x greater than 11. So probability that x equal 12, probability that x equal 13, probability that x equal 14, all the way to the probability that x equal 20, all the way up to n. Okay, you could do it that way, or you could go like this and say, well, the probability that x is equal to, or that x is greater than 11 is 1 minus the probability that x is less than or equal to 11. Okay? Then furthermore, we could say, well, that's just 1 minus the probability that x is equal 11, x is equal 10, and then essentially x is equal 9, x is equal 8, but we can call that probability that x is less than or equal to 9. And we just do that because that's what we just solved for, right? We know this number. So we get 0.4119, and then we just look at the table to find the values for x equal 10, which is 0.1762 and 11.1602. Is that right? That's right. So we add those up, minus those from 1, and that's going to give us 0.2519. Okay, B3. Fewer than 5 dish owners in the sample subscribe to at least one probability or one premium movie channel. Fewer than 5. So probability that x is less than 5. And so that's just going to be, I would just call it the probability that x is less than or equal to 4, which is really just probability that x is equal 4 plus the probability that x is equal 3 plus the probability that x is equal 2 all the way on down. And that is going to be 0.0046 plus 0.0011 plus 0.0002 plus some zeros is equal to 0.0059. And now C asks, suppose that when we survey 20 randomly selected dish owners, we find that 4 of the dish owners actually subscribe to at least one premium movie channel. Using a probability you found in this exercise as the basis for your answer, do you believe that the industry representatives, or do you believe the industry representatives' claim? Explain. Well, so first off, let's just write this. So the probability that x is equal to 4, we know is 0.0046 from the table. This is very similar to the last problem that we did, in that if we were to assume that 50% of all owners, all cable subscribers subscribe to at least one premium channel, then the chances that we would only draw 4 successes out of the 20 sampled are 0.0046, right? So less than 0.5%. So we would say no, we don't believe that that claim is true, because if that claim were true, the likelihood of us getting this result is so paper thin. Okay, so that's C. Suppose that the random variable z has a standard normal distribution. Sketch each of the following z points. Use the normal table to find each z point. Okay, so we did some work with the standard normal curve and calculating z values during the normal exercises portion of this worksheet and of the lecture and whatnot. So this is taking it kind of backwards, right? This is saying that we're going to have z values where we know the amount of probability that's on one of the tails, and we want to look up in the table what the z value is. Not conversely what we did last time, or maybe what we'll do here in the next problem, I believe. And basically what I'm saying is there's 2 ways to use the table. You can have a probability in mind that you are looking for a z value for, or you can have a z value and be looking to find what the probability is above or below it. So this is going to be the one where we have a z value that has an associated probability, and we need to find out what that z value is. Okay, that's the one that we're going to be doing right now. So if we look at A, don't mind the extra A's and don't mind the extra A's and B's and C's and stuff in there. cross these out. All right, so for A, Z of 0.01. Okay, so Z of 0.01 oh, for goodness sakes. Anytime you do that, you are opening yourself up. Okay. Z of 0.01. This is where we're going to leave 0.01 of the probability in this right-hand tail. So we can say we have 0.01 of the probability here, and we have 0.99 of the probability over here. But this is the tail that we're looking at, and this is the z-value that we are looking for. Okay, where the line is, there's 0.01 probability above it. Okay, so that's A, and so now we got to go to the tables. So we're not in binomial anymore. Now we got to go to the normal tables. I believe they are right here. So there's two different normal tables. This is for all the negative values, and now we have to look for the positive values, because as you can see, we're at a z-value that's on the right side of the graph. See here, we look here. This is dealing with values that are left of the mean, so on the left side of the graph. This is dealing with values that are on the right side of the mean, so the positive values. So now we actually have to, we're not looking here, we're looking inside of the table to find out where 0.01 of the probability lies on the right side of that z-value. And then also we could look at it as conversely 0.99 of the probability lies on the other side of that, right? And since we know that this table is cumulative, meaning that it measures the probability from left to right, we know that realistically we're looking for the value 0.99 or something that is very close to 0.99. Okay? So we look in here, we've got a lot of 0.9995, you know, everything like really high. We go up here, we got some 0.82, 0.86. So we go and we want to just scan this, and we want to, like, we're looking at z-value of 0.20 all the way over, get all the way up to 0.98. I see a 0.99 here. Okay, so now we're at 2.3, so we're going over 0.9893, 0.9896, 0.9898, 0.9901. So that's the closest one to 0.99. Right, so this means that 0.9901 of probability is to the left of this z-value. So roughly 0.01 is to the right of it. So what is that z-value? All right, so at this point right here, we look here, we have 2.3, and then the second decimal is 3. So 2.33. So that's our z-value. 2.33. So we're going to do B. B is z of 0.05. So similarly, we draw our graph, because it's more of an imply, not an equal to. Okay. Sorry for my terrible normal curve. So this is the area that we're looking for, and this is where 0.05 of the probability is over here. 0.95 is over here. So this is the z-value of 0.05, and that is equal to what? So this is where we want 0.05 of probability on the right-hand side, or conversely 0.95 of the probability on the left-hand side. So in the same way that we looked for that 0.99, now we got to look for 0.95. And I'm looking here at like 1.6-ish, all the way over, we got a 0.9505, and so that's the one we'll use, I guess. So we look to see, so it's this one, 1.65. Okay, so you go back over, 1.65. C, z of 0.02. This is going to be the exact same concept. So this one. So 0.02 is right here. 0.98 is in here. So this is a z-value of 0.02 is where? So we want 0.98 to be to the left of it. So we're looking for 0.98 here, the thing that's closest to 0.98. And it looks like we have a 0.9803, and that is going to be 2.06. 2.06. Okay. And on to D. D is negative z of 0.01. So we can do this a couple of different ways. Yeah, I mean, I guess either way you want to do it is fine. So what they're really asking for here is for you to draw this curve and then look for this area right here. And my word is not responding. Okay, and now it is. All right. Come on. All right. I want you to find this area right here. So 0.01 right here. So this is going to be z of 0.01 or negative z of 0.01. And really, you can, because we know that this curve is symmetrical, we already calculated the probability of it being 0.01 on the right-hand side, and that's just z of 2.33. Now, if we were to look at this other table, so we go up and we look at the negative table, we can actually just go to 2.33, and we'll find that it is very, very, very close to 1. So it's the same thing. They're symmetrical. So we can just know that this is just negative 2.33. Okay, so then E is going to operate similarly. So the bottom 0.05. And we already solved for 0.05, so this is just going to be a negative 1.65. And then the only new one that we have to do is F, which is negative z of 0.10, which is like this, bottom 10%. So it's nice when you're working with the negative numbers because whatever probability they give you, that's just what you're looking for in the table. You're not like looking for the 1 minus that. You're just looking for that probability. So we got to look for probability inside the table that is closest to 0.1 or 0.10. So we're looking over here, and we want to find something that's close to 0.1. Okay, we're getting warmer right here. 0.1003, and that is a negative 1.28. There you have it. So that's how you look up z-values for specific probabilities there. All right, suppose that the random variable x is normally distributed with mean is equal to 1,000 and standard deviation is equal to 100. Sketch and find the following probabilities. Okay, so this is going to be a more standard example, not like what we did in the last problem. This is going to be us wanting to take what we see here, find z-values, and then go to the table and use those z-values. And I don't know if I'm going to run through all of these because this is a lot of work, and I feel like after a few of them you might just get the gist. So yeah, maybe I'll just do like 4 of these, and then if you have any questions on E through F, then you can post those in the discussion forum, and I can answer those questions. Okay, so A. So we're looking to find the probability that x is between 1,000 and 1,200. Okay, so the first thing that we want to do is we want to normalize this, or we want to standardize this. So we want to find what the z values are, because that's going to be the only way that, well, I guess the first thing we want to do is we want to graph this, because didn't it say that? Sketch the probabilities. So, jeez. Let me get rid of that. This is a bad looking. There we go. Okay. So that's normal, supposedly. And we assume that the mean is 1,000, so mu is equal to 1,000. And standard deviation is equal 100. On all of these, we assume that. And so we want to find the probability from 1,000 to 1,200. So we'll just assume that this is 0.1200. So this is the portion of the graph, because the mean is in the center, and that's 1,000. So we want to find from 1,000 to 1,200. So this is the probability that we're looking for right here. Okay, so the way that we go about this is we want to find the z-scores, or the z-values, of each part of that probability. So the 1,000 and the 1,200. Well, the 1,000 is really easy. So we'll just do the 1,000 first. And remember, the z-score is z is equal to x minus mu over standard deviation. Okay, so this will just be 1,000 minus 1,000 over 100, which is just going to be 0 over 100, or 0. Okay, so that's the z-value of that. And then 1,200, we want to find the z-value of 1,200. So we'll say 1,200 minus 1,000 all over 100, and that's going to be 200 over 100, or 2. Okay, so now we have z-value of 0 and z-value of 2. So now we want to say probability that z is between 0 and 2. Okay, well, this is, we know, so we could measure the probability that z is less than 2, and then we could minus off the probability that z is less than 0. Because the probability that z is less than 2 is going to give us all the way back to the whole left-hand side. And then what we could do is then minus off the portion that we don't want, which just happens to be the probability that z is less than 0. So that we can just say the probability that z is less than 2 minus the probability that z is less than 0. Okay, so we just go to our table. We want to find the z-score of 2 and find what the cumulative probability of that is. So we go down to 2, and that is just, and we don't have any other trailing decimals, so just 2.0. So that's 0.9772. And then we would find the probability that z is less than 0. So we look right here, z is equal to 0, and not surprisingly that it's exactly 50%, 0.500. So that makes sense, because a z-score of 0 implies that we're right on the mean, and we know that as an identity of this normal curve, is that 50% of the probability lies on one side, 50% is on the other side. So we just do the math here, and this 0.4772 probability is the probability that we are in this region right here. Okay. So B, probability that x is greater than 1257. Okay. And like I said last time, first thing we want to do is calculate, I guess we'll draw it. They want us to draw it. So that's the mean. And then here's say this is 1257. This is the probability we're looking for. Okay, right there. So let's calculate the z-score. Z is equal to 1257 minus 1,000, which is our mean, all over our standard deviation of 100, which is going to be 257 over 100, or 2.57. Okay, so this is our z-score. So now we want to go, but now because we're looking for the area, or the probability above, the way that we would do this is we would say, well, this is going to be equal to 1 minus the probability of z is less than 2.57, because really what we want is the probability that z is greater than 2.57. Okay, so we go over here and 2.5 down on the z all the way over to 7, and that's 0.9949. So this is going to be 1 minus 0.9949, or 0.0051. Let's see. Probability that x is less than 1035. Okay, 1035 we know is to the right of the mean because it's greater than that, but it's like right here. And we want to know the whole probability that's less than that. So this is going to be the easiest form of this, because we just calculate the z-value and then we can just straight up look it up in the table. So calculate the z-value. Uh-oh, this is supposed to be 100. So we get 35 over 100, or 0.35 for our z-value. So we can take 0.35 to the table and look it up. Z of 0.3 all the way over to 5, and that's going to be 0.6368. So that's the probability that z is less than 0.35 is equal to 0.6368. Which is also, this. And D, x between 857 and 1183. Oh my goodness, my pen is killing me right now. Okay. What did we say it was? Probability 857, x less than 1183. So this is going to be one where we're going to be finding two z-scores. So let's first find the z of the 857. Be negative 143 over 100, so negative 1.43. Oops. 1.43. And then 183. And that's going to be 183 over 100, which is 1.83. So then this is just going to equate to the probability that z is between 1.83. Oops, that was a negative. There we go. Which, like last time, is going to be probability that z is less than or equal to 1.83 minus probability that z is less than or equal to negative 1.43. Okay. And so then we would find so here, I will just arrow this over here. So the probability that z is less than 1.83, we just look it up in the table. Z 1.83, and that's 0.9664. And that's going to be minus the probability that Z is less than 1, negative 1.43, negative 1.43, 0.0764. And that is going to equal 0.89 on the dot. All right, so that's all we're going to cover for that one. Just because if I did all these, like, this video is just going to run on forever. We're already going on close to an hour. So yeah, if you have questions on any of those or EFGH, let me know in the discussion, and I'll be happy to answer any questions you have, guys. Okay, 13. Suppose that X has a Poisson distribution of mu equal 2. Use the formulas given in the section to compute the mean, variance, and standard deviation. Okay, well, we know from the formula that, we know from what is given, mu of x is equal to 2. We also know from the formulas given in the section that the variance is equal to the mean, so that's 2. And so then we know from just our general knowledge of variance and standard deviation that this is the square root of the variance, which is going to be the square root of 2. So that is A. And then calculate the intervals mu of x plus or minus 2 standard deviations and mu of x plus or minus 3 standard deviations. Then use the probabilities you calculated in exercise 5.3, which I believe that is actually the last Poisson problem that we did in class. So that's going to be, well, I'm not going to scroll all the way up, but it was the Poisson problem. I think it's maybe number 4 or number 5 or something on this worksheet. So we just use those probabilities to calculate these intervals, okay? And so we'll go ahead and do this. So mu plus or minus 2 sigmas. So this range is going to, I'll just do them both at the same time. Mu plus or minus 3 sigmas is going to be, so from somewhere to somewhere, right? And actually, let me erase some of that. Okay, so we'll just say this is 2 minus 2 times the square root of 2. So 2 being the mean, minus 2 being the 2 that's given to us here, and the square root of 2, which is sigma x. And that is from 2 plus 2 times the square root of 2. And then this is 2 minus 3 times the square root of 2, all the way to 2 plus 3 times the square root of 2. And this is all going to shake out to negative 0.82. There. Let's erase that. Okay, that's going to be negative 0.8284 all the way to 4.8284. And this is going to be negative 2.2426 all the way to 6.2416. Oh, 2426. Either way. All right, so it says then use the probabilities that you calculated in exercise 5.3 to find the probability that x will be inside each of the intervals. Okay, so right now we've established these intervals, and now notice these are like really messy numbers, right? But Poisson is a discrete distribution, so our x values are going to be zeros, ones, twos, threes, stuff like that. So this we can boil down to, so let's look at the first interval, the plus or minus 2 standard deviations away from the mean. So if we want to be in that interval, so I'll just put an arrow. For this interval, we're just going to be looking at the probability. Oh, and notice because this is discrete and it's Poisson, x is only defined from 0 up through, some big number. So this is actually just going to be the probability that x is less than or equal to 4, right? Because 5 isn't in our range that's defined over here. And we don't have any use for negative numbers. So really we're just looking at the probabilities of 0, of x equals 0, x equal 1, x equal 2, x equal 3, and x equal 4. Okay? And then similarly, for the next one, we're just looking at the probability of x is less than or equal to 6. And that's it. So then we would go back to the prior problem, and we would calculate those probabilities, which I'll let you guys do, because again, this is getting long in the tooth. 9, 4, 7, 6, 9, 9, 5, 7. Okay, and again, that would just be, like, so for x is less than 4, this would just be 1 minus the probability of x equal 4, minus probability of x equal 3, minus probability of x equal 2, 1, and 0. Okay? And then similarly, 1 minus the probability of x equals 6, x equal 5, x equal 4, all the way on down to 0. Okay, let's move on to 14. A telephone company's goal is to have no more than 5 monthly line failures on any 100 miles of line. The company currently experiences an average of 2 monthly line failures per 50 miles of line. Let x denote the number of monthly line failures per 100 miles of line, assuming x has a Poisson distribution. Okay, so the first thing I notice is they're wanting to, okay, well, yeah, let's just read A. Find the probability that the company will meet its goal on a particular 100 miles of line. So assuming, so it looks like we have a mu of x equal to 2, but that's like per 50 miles. Okay, so if we're looking at something that's not 50 miles, we have to actually move this mu accordingly. So let's do A. Find the probability that the company will meet its goal on a particular 100 miles of line. Okay, so if we're referring to 100 miles of line, we just multiply this. So what do we multiply to get to 100? We multiply it by 2. So then we would multiply this by 2 as well. Okay. So for A, mu of x is going to be equal to 4. Okay? So we got to use our Poisson distribution to find the answer to the problem. Find the probability that the company will meet its goal on a particular 100 miles of line. So the goal was what? The company's goal is to have no more than 5 monthly line failures on 100 miles of line. So this is the probability that x is less than or equal to 5, no more than 5. Okay, so we just go to our Poisson table where our mu is equal to 4. And we want to add up the probabilities from 0 to 5. So let's go find our Poisson table. Poisson. And mu, we are looking to be 4. Mu 4 over here. And we want to add up the probabilities from 0 to 5. And that looks like we are right in that range there. So that's going to look like x equals 5 plus x equals 4 plus probability of x equals 3, all the way down to the probability of x equals 0. And then we just add those up. So you guys saw those just on the table. So hopefully you're looking at your table now, but I'm looking at my notes. So I'm just going to write them off of here. And that would equal, so the probability that the company meets its goal or has less than or equal to 5 monthly line failures is 0.7852, or roughly 78.5%. Okay. So B, find the probability that the company will not meet its goal on a particular 100 miles of line. Well, that's going to be easy. We know the probability that it does meet its goal. So this is just going to be the probability that it does meet its goal. And that's just going to be the probability that x is it's going to be 1 minus the probability that it does meet its goal. So if it doesn't meet its goal, that means its x is going to be greater than 5 failures, which is going to just be equal to 1 minus the probability that x is less than 5 failures, which is 1 minus what we just calculated, so 78.52 equals 0.2148. Then we move on to C. Find the probability that the company will have no more than 5 monthly line failures on a 200 miles of line. Okay, so we need to adjust our mu for that. So for 200 miles of line, we're going to expect mu to be 8. Okay, because that's just all linear. So then we go to the appropriate Poisson table. So we find mu equal to 8. Oh, there we go. Mu equal 8 right here. Okay, and we're just going to say, well, what is the definition of meeting our goal? Definition of meeting our goal is less than 5 failures. So similarly, probability of x equal 5 plus the probability of x equal 4, blah, 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 all the way down to the probability of x equals 0. So we add all those up, but this is in a new table. And so we have mu equal 8. So 0 is 0.0003. Okay, 1 is 0.0027. Okay, I'll read the rest off my notes here. 0107 plus 0286 plus 0.0573 plus 0.0916. That's all going to add up to 0.1912. So roughly a 19% chance that they meet their goal of less than or equal to 5 line failures in 200 miles of line. Okay, recall in exercise 5.32, page 208, that the number of customer arrivals at a bank's drive-up window in a 15-minute period is Poisson distributed with a mean of 7 customer arrivals per 15-minute period. Define the random variable x to be the time in minutes, so not in 15-minute periods, but in minutes, between successive customer arrivals at the bank's drive-up window. Write the formula for the exponential probability curve x. Okay, so we're defining this on a per minute basis. So our lambda is not going to be 7. So 7 customer arrivals we know is per 15-minute period. So our lambda is actually going to be 7 divided by 15. So we'll just say lambda equals 7 divided by 15. So then we know that our function, our f of x, is going to be equal to, just plugging that lambda into the formula, 7/15 e to the negative 7/15 x. And that's 0 otherwise. And this is just for all x greater than 0. And then B says, so this was for A. B says sketch the probability curve. Probability curve, oh geez. Okay, probability curve has the height of lambda, so 7/15. Okay, and then it just sort of diminishes like that. Okay, that's our probability curve. Hopefully you guys can draw that better. This is about as good as I got with this web or with this computer pen. So you can go in the book and look and find better examples. Okay, and then speaking of my computer pen and Word, they're not agreeing, so whenever you are ready, pen, to come back to life. Okay, there you go. So let's do C. Find the probability that the time between arrivals is between 1 minute and 2 minutes. So C1. So this is just the probability that x is between 1 and 2. Okay. And we just go to our formula. In the notes, our formula is just going to be e to the negative lambda a minus e to the negative lambda b. This being 1 being a, 2 being b. So a being the beginning of the interval, b being the end of the interval. And so then this is just going to be e to the negative 7/15 times 1 minus e to the negative 7/15 times 2. And that's going to be 0.6271 minus 0.3932, which equals 0.2339. C2, the probability that x is less than 1. Okay, and then we go to our formulas in the PowerPoint slides, and it's going to be 1 minus e to the negative lambda a. Okay, and that's just going to be e to, or it might be 1 minus e to the negative lambda b, but either way, whatever the number is in there that you're using, you're only given one number. Okay, and that's going to be 3729. C3, more than 3 minutes. This is just going to be e to the negative lambda times that number times 3, which is just going to be 0.2466. And then C4, between half and 3.5 minutes, so probably that 0.5 is between x is between 3.5. Okay, and we use the same formula that we used in C1. So e to the negative 7/15 times 0.5 up there minus e to the negative 7/15 times 3.5. We do all the math. Okay, D, calculate the mean, the sigma, the mean, the variance, and standard deviation. Okay. Okay, and the mean we just know is 1 over lambda. So the mean of x is equal to 1 divided by lambda, which is just going to be 1 divided by 7/15, which is equal to 15 sevenths, which is equal to 2.1428. And we know that sigma is also equal to that. And so then conversely, sigma squared is equal to the square of that, so 4.5918. In E, find the probability that the time between arrivals is within 1 standard deviation of the mean, within 2 standard deviations of the mean. Okay, so if I have room, I'll do both, but let's just do the first one, because I don't think I'm going to have room. So the probability that, so we'll say E is the probability of sigma x plus or minus our mu of x plus or minus sigma x, which is the probability that x is between sigma x minus, x is between mu of x minus sigma x and mu of x plus sigma x, which, if we calculate it, it's going to be x is between 0 and 4.2856. And then we just run the formula that we did in C1 or C4. And we get e to the negative 715 times 0 minus e to the negative 7/15 times 4.2856. So it's going to be 1 minus 0.1353 or 0.8647. Yeah, I didn't have room to do the second one, but you guys can figure it out. Okay, and I believe this is, goodness, hopefully our last problem. Longest review session ever. The length of a particular telemarketing phone call, x, has an exponential distribution with mean equal to 1.5 minutes. Write the formula for the exponential probability curve of x. Okay, so first thing I would note is it says that mu of x is equal to 1.5 minutes. All right, and so then we know that lambda is equal to 1 over mu of x. So we just know that that's equal to 1 over 1.5, or 2/3. Okay, so that's our lambda first off. So write the formula. Two-thirds e to the negative 2/3 x for all x greater than 0, 0 otherwise. And the graph is just lambda. Yeah, that's as good as I can do. All right, so let's do C. Find the probability that the length of a randomly selected call will be no more than 3 minutes. So the probability that x is less than 3. And this is just similar to last time. So this is going to be 1 minus e to the negative lambda times x, which is 3, which is 1 minus e to the negative 2. 0.647. Okay, so that's C1, C2, between 1 and 2 minutes. So x is between 1 and 2 minutes. This is just going to be e to the negative 2/3 times 1 minus e to the negative 2/3 times 2. And that's going to be ultimately 2.4 or 0.2498. C3, probability that x is greater than 4, and that is just going to be equal to e to the negative 2/3 times 4. Okay. Or e to the negative 2/3 times 4. Yeah, that's the better way to put it. Or better way to emphasize it. Okay, and C4, probability that x is less than 0.5. And that is just going to be 1 minus e to the negative 2/3 times 0.5, which is 1 minus e to the negative 1/3, which just shakes out to be 0.2835. All right, guys, that was the review. Sorry that the video was an hour and 20 minutes long. We got through it. Hopefully you'll find this useful. If anything that I was unclear on, or anything that you wanted more detail on, or just had any flat out questions on, whatever it is, email me or write it in the discussion forum so that I can answer it for everybody. But thanks so much for tuning in. I hope that this was helpful. But don't be afraid to ask questions. And until next time, thanks so much.